Okay class, hey, this is your electron configuration practice problem video. Before we start, I do understand this is a tough topic, and hopefully this video is going to help break some of that down more for you and give you an idea just how we go through these types of problems and what you're expected to do and see. In saying that, let's start with our main points, just some ideas and things to keep in mind as we go through these problems. The first thing is we need to know how many electrons each orbital can hold. So just to refresh yourself, our s orbital has one suborbital and it can hold a total of 2 electrons. Our p orbital can hold 3 suborbitals and a total of 6 electrons. Our d orbital can hold about 5 suborbitals for a total of 10 electrons. And our f orbital is a really big one that holds 7 suborbitals and has 14 total electrons in it. Outside of knowing how many electrons we can have in each orbital, we need to know the proper order in which these orbitals will present themselves. On the screen now, you should be seeing the electron orbital diagram, and from there we will start working through what we need to do and working these problems out. I strongly suggest that you memorize how to draw this out and how to actually know where the arrows are going to go and which way everything's going to go. So our questions are going to be: find the electron configuration for each of the following elements: carbon, sodium, iron, bromine, and arsenic. Notice I'm not asking for the quantum number here. We'll do that in another video, but right now I just want you to be able to identify what orbitals electrons are present in. So again, we're going to find the electron configuration for each of these neutral elements. So starting off with carbon. Carbon's atomic number is 6. That means it has 6 protons. Since it is neutral, that means it has also 6 electrons. So we're going to have to account for 6 electrons through this electron configuration. We always start up at the top at 1s. So we have 1s2. So we had 6, we used 2 of them up, so that gives us 4 total left. Then we go to 2s2, so we're at 1s2, use 2s2. That means we've used a total of 4 electrons. We're trying to get to 6, remember? So now we're going to move on to our 2p orbital. Okay, it can have, remember our p orbital can have a total of 6 electrons, but we only need 2. So this is going to be 2p. That gives us a total of 6 electrons. So 2 electrons in 1s, 2 electrons in 2s, and 2 electrons in 2p for a total of 6 electrons. That means our electron configuration is going to be 1s, 2s, 2p. Now let's go to sodium. Sodium has an atomic number of 11, meaning it has 11 protons, and since it's neutral, that means it has 11 electrons. So we'll start on off like we did our last one. 1s, that can hold 2 electrons. 2s, that can hold 2 more, so now we're at 4 total electrons. Next thing we can go to is 2p. This time, since we're wanting 11 total electrons and we only have 4, we can fill our p completely up so that it can hold 6 electrons, giving us a total of 10 that we have used so far. So right now we have 1s, 2s, 2p, but we have one more electron we got to account for. So we're going to have to go into the 3s orbital. And so that's going to give us our 1 extra electron we need to give us our electron configuration of 1s, 2s, 2p, 3s. The key thing with these, as we're noticing, is just keep track of how many electrons you have left or how many you've used at every step. That's going to make it easier for you to understand and not mess up. So now we go to iron. Iron's a transition metal and it has 26 protons. Since it's neutral, we're going to say it has 26 electrons as well. So starting our way through the electron orbital diagram, we go 1s, that's 2 electrons. 2s, that's 2 more electrons, giving us a total of 4. 2p6, or 2p, we fill that all the way up, and that's 6 electrons. So now we've used a total of 10 electrons, one from 1s, or 2 from 1s, 2 from 2s, and 6 from 2p. So that's 10 so far. We need 26, so we gotta keep going. 3s, we fill that up all the way. That gives us 2 more to give us 12 total electrons. Then we go to 3p, and that's 6 more electrons if we fill it all the way up to give us a total of 18 electrons that we've used. And we're trying to get to 26, and we've used 18. So now we go to our 4s, and we fill that up, and that's 2 more electrons. So now we're at 20. So through 20 electrons, we're 1s, 2s, 2p, 3s, 3p, 4s. We need 26 electrons, so we got to keep going here. The next thing we would go to, the next orbital we would go to, would be your 3d orbital. Remember, your d orbital can hold 10 total electrons. Well, we only need 6 more, so we're just going to put 6 in the d orbital. But in saying all that, it gives us our electron configuration of 1s, 2s, 2p, 3s, 3p, 4s, 3d. Okay. Now we're going to bromine. Bromine has 35 protons, so that means it also has 35 electrons if it's neutral. Starting off with the electrons, we have 1s is what we're going to fill first, that orbital first. That has 2 electrons. Then we go to 2s for 2 more for a total of 4 electrons used so far. Then 2p, which we fill that up, and now we've used 6 electrons in the p orbital and 10 total electrons. Then we go to 3s. That's 2 more electrons for 12 total electrons. Then we go to 3p for a total of 18 electrons. That's 6 electrons in the p orbital. And we just added those 6 onto our 12 from our last section to get 18 total. So now we go to 4s. We fill that all the way up and we get 2 electrons in that orbital for a total of 20 electrons so far used. Remember, bromine has 35, so we're at 20. So let's keep going. Next is our 3d orbital. That one can hold 10 electrons, so we're going to fill that up for a total of 30 electrons now. Well, we're needing 35, so we need to keep going here. Now we can go to our 4p orbital. Remember, p orbital can hold 6, so we can just put our 5 remaining electrons there. And that's going to give us a total electron configuration of 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. Okay, so our last element is going to be arsenic. Arsenic has 33 protons. That means it also has 33 electrons. So we start out normally with 1s, and that's 2 electrons. Then we go to 2s. That's going to be 2 more electrons, giving us a total of 4 electrons. Then we go to 2p. That's going to fully fill up and give us 6 more electrons, so a total of 10 electrons. Then we go to 3s, which is 2 more electrons. So we got 3p on top of that with 6 more electrons, giving us a total of 18 electrons. Then we have 4s, which gives us 2 more electrons for a total of 20. We need 33, so we need to keep going. 3d, if we fully fill that up, that's 10 electrons, and that gives us a total of 30, so we are almost there. So now we go to the 4p orbital, and we only need to fill that one up halfway. Even though it has 6 total electrons it can have, we only need to fill it up with 3. So that gives us an electron configuration of 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. So I hope these practice problems kind of helped you out, gave you a little bit more understanding. There's going to be 2 more practice problem videos over these kind of things, dealing with quantum numbers and then electron spin. So we'll just take this one step at a time. This is the first step, dealing with the electron configuration. So in saying all that, keep up the good work, and we'll see you next time.